is she? Hey, my golly, we're doing it again, fellas. Exploring the cosmos. I got the brain trust of Santa Barbara, California, longtime astrophysics club, and myself, your
My
host.
golly, we're doing it again, fellas. Exploring the cosmos.
Uh-oh, I'm hearing myself back.
California, long time
That figures.
astrophysics
Well,
club.
anyway.
And
Somebody's got the sound on the live stream.
Pause.
Exploring the cosmos.
We're going to pause just a moment
Uh-oh,
here,
I'm
folks.
hearing
I'm
myself
talking
back.
too much.
Okay. Sorry, I forgot to turn that off.
Well, look, this is our 277th program of the Astro Hour, SBAU Astro Hour, for June 15th through the 22nd, 2026. And it's all for you guys as an educational service once a week, Monday mornings on YouTube from our proud club, the Santa Barbara Astronomical Unit. We are in our 6th year, gang, but there's plenty to talk about. New space launches, cosmic discoveries, and theories of physics are surfacing all the time. Our club meets once a month, on the first Friday, usually out at the beautiful Santa Barbara Museum of Natural History. We even meet outside at night there for our second Saturday star parties a week later. Otherwise, we're incredible with outreach. It takes us everywhere, schools, hotels, state parks, and all, maybe to your event if you want. Call us. We even do the public on Sunday. We line them up to look at the sun. This week's hot topics. Here's what we're going to talk about. Tomorrow's midday. Our moon will pass by Mercury, then form a triangle with another of the planets, the biggest one, Jupiter. Our current comet is McNaught. It's just a few degrees west of Saturn. We're going to talk about our Earth and looking for a twin. Pretty unique, The SETI search has not yet found an exoplanet with the same characteristics for life. It's kind of sad. Can't really look right at the smaller rocky planets like our inner solar system. Got to use indirect methods. Plus an update on where we stand. What does Earth's current spectrum look like? NASA's next space telescope has been designed to do what previous instruments could not. It's the HWO. And listen, the update news of the day, which we'll be talking about in later programs, is NASA picking 4 men as the astronauts for the Artemis 3 mission next year. It's going to be around the Earth mostly. Let's talk. Let's meet the gang. I don't have my names, but I know you. I wouldn't need that list. What am I talking about? Here's the president of the club, who is the professor of the show, Dr. Jerry. We don't call you that much, but you do have one, right? A PhD. Jerry Wilson.
Yes.
And the ladies?
Yes, and my hello to my sister Joyce and my grandkids Riley and Calvin.
And Pat Forgy is somewhere in the
Forgy, my wife.
She is a doll of a lady. I got to tell. It was grand sharing the table with you and another member of our screen on Friday night at our potluck. His wife is Pat Forgy. Chuck McPartland is the most incredible outreach in the world. And I think Chuck may be reaching an age when he's just sick and tired of setting up his scope. We don't mind because he's got the pet rock from hell out there at the star parties. But hell, you're working this week, aren't you?
Yeah, we're pretty busy almost every night. So,
and you're going to be there. How many times are you going to set up your scope this week?
Tuesday, Wednesday, probably not on Thursday, but Friday and Saturday, depending on the weather too.
We can forgive you and excuse you for not setting it up on Friday. It overcast, and I thought about that later. He knew it was going to do that, and he didn't want just an hour of seeing stars. Anyway, he's married to our incredible merchandise manager and treasurer, Pat McPartland. Here's Tim Crawford, who's married to Karen.
Hi, and I'd bet Friday's going to be foggy again.
Now, have a positive outlook.
I'm a pessimist today.
But you're there Sundays at the museum at Palmer Observatory when it's bright and beautiful, and we're looking at the sun. And
oh, it was great.
It was great, but it was hot.
It was great.
There were some flares, I heard. Jerry said you
Prominences.
Prominence.
It was a really great prominence.
Yeah.
And your wife is Karen, and Tom Whittemore shared my table at Friday's potluck. He's married to Maureen.
Morning.
delicious
It
potato
looked
salad.
just like that, Ron.
Did it? What? What did you say?
It looked just like that behind me.
Oh, you guys keep changing the background. It drives me nuts. It's
Wow.
amazing. I got to figure out a way to get a background on me. I just blurred. You don't want to see the.
That's not actually a picture from last Sunday.
No,
Oh, it's not.
This
Did
is a
you get? Did you
combination.
get any taken? Did anybody?
no.
Is there a camera?
There was a prominence that might have been about 5 Earth diameters out,
Yeah.
and width-wise, it was probably about 7 to 10 Earth diameters wide. It was really big.
Can you see it moving?
No,
If you
can't, it's just there.
if you wait an hour or more, you can see that it has moved. It's changed its shape a bit.
yeah.
Okay, and if it were coming toward us from the middle of the sun, we wouldn't be able to see a thing, would we?
It would look like these dark filaments you see in this picture.
Yeah.
Yes.
Ah, okay. Well, gentlemen, let's do the sillies and then we'll talk more about this. We got a busy hour and this is number, what is it, 277? Wow, in our 6th year. These are the funnies that are emailed to us, forwarded by President Jerry, including this one that I don't even recognize. What the hell is? Oh,
I
that's
didn't see the funnies, so this is hilarious.
Observatory turned Pac-Man.
Yeah.
It's
Is there a
reaching for the
caption to this?
moon.
What?
It's reaching for the moon.
That's
Yeah.
right. It looks just like the Pac-Man. But they make them square nowadays, don't they? Down in Chile, anyway.
No, they make them any shape.
Yeah.
There's a company that will sell this clamshell type thing made out of reinforced plastic for your backyard.
But it's fair to say that in the old days, they froze their garbanzos off in there, didn't they? Now they're over in a warmed office looking at a computer screen, right?
The scientists are, the graduate students are still freezing up in at altitude.
Yeah, we used to have a clamshell at Westmont.
Yeah.
No way you could enclose the whole thing and let them look through glass. That doesn't work. Okay, Mr. President, what's going on here? In a
Oh,
line?
Well, the guy has brought his friend to the moon with him. One giant leak for dog kind. Are you sure you want that to be your immortal quote?
pretty good.
We're going to have to think about that eventually. Here's another version of that, I guess.
Yeah. This is the Earth to Mars mail. And they're watching the mail ship come in and the dog is growling because he doesn't get to chase the mailman.
This is a new one. I didn't get this one. I got the pizza delivery one. Are we doing that? Pizza to Mars. There it is. Chuck, you want to guide us to what's happening from Bob's?
Bob's Pizza of Houston delivering to Mars. That'll be $1 trillion.
Like that.
So Musk can afford it.
Yeah.
Right. That a scene
On paper.
from a Matt Damon movie, throwing his potatoes and getting a delivery. Okay, talking heads. Who wants to try this? Tim, you think you can diagnose this?
I'll try. Let's see. They landed on the moon. You really believe that species is capable of memorizing 5 items on a shopping list can actually land on the moon?
And who's doing the talking?
This
Yeah, I guess it's probably a robot. Probably the
True robot.
AI robot.
Yep. With
yeah,
a
it
human.
says you really believe that a species incapable of memorizing
Right,
5 items.
right.
Oh, I see. Okay.
All right. Here we go. Speaking of extraterrestrials and the new Steven Spielberg movie, you want to try this, Mr. Whittemore?
Sure, it says, come on, everyone, smile. And they do. That's better.
That's how they smile. It looks rather pornographic, those smiles. Can you enlarge this at all? There you go. Chuck, you again.
Okay, this is an XKCD, and you've got scientists going up a ladder looking down the beam pipe of the Large Hadron Collider going, this year's Physics Nobel will go to the scientist who figured out that you can make the Large Hadron Collider more powerful by covering part of the beam pipe with your thumb.
Obviously, they have hoses. They have hoses in their gardens.
Yeah.
Those guys. Okay. Good stuff. Gets us in a good mood every week. They're all archived, aren't they? All 277 of them, because we've never missed a show without silly cartoons. All right. Let's get into the heavy thinking stuff. The night sky.
Mhm.
Actually, it's the morning sky, isn't it?
Nope.
No,
Oh,
this
that's
is
night. That's evening.
June
Yeah.
16 down here, so that's tomorrow night.
Yeah.
30 minutes after sunset. It's obviously not a photo because
Yeah.
this is from the sky. Oh, evening. It's from yeah, it looks like it's from one of the sky softwares.
Yeah.
But
And the movement, Jerry, of Venus night after night after night has been just dramatic.
yes,
A week ago, it was sitting to the side of Jupiter. Okay, and now it's hooked up with Pollux and Castor. I didn't catch Mercury last night. I looked for it. I think it was a little hazy, but it's just amazing to me that we're still able to see Mercury. And you can see how the ecliptic, containing Venus, Jupiter, and Mercury and the moon, is just cranked. It's just super cranked. So these are really good apparitions of the planets.
yeah,
We had
it's
we
a
had
nice
10 minutes of Jupiter on Saturday.
it's a nice, easy evening sky to look at.
Oh, it's just beautiful.
10
Yeah.
minutes before the clouds rolled in.
10 minutes before we got fogged over.
Oh, I see. I was in Ojai Music Festival.
Yeah, it was clearer there.
It was in the 80s, Jerry.
Okay. This is a picture of what it will look like in a few days, but several years ago. This is a picture taken in December 2015, when the Venus was occulted by the moon. And at this time in 2015, the moon goes over Venus. The occultation that's going to happen this week is that the moon is going to what is it when it reappears?
Emergence.
Thank See, my questions aren't difficult. I just don't know the answer.
Yeah.
That's the
So,
relative sizes of them when we look through our
Yeah,
scope.
Chuck, it's an emergent phenomenon.
Yes.
yeah.
And the times in the document you sent out are UTC. So you're
Oh,
gonna have
yes,
to track
yes.
7 hours.
Yes. Okay. So this is a very early, very crescent moon, and that's just past new moon, and where our moon is gonna not be bright like that.
Huh.
Not this is bright, but it's gonna be dim like this.
Yeah.
But that picture was 2015, you said? 11
Yes.
years ago?
Yes. But this one on June 17th is going to be 11:38 is when the moon covers Venus from its side that isn't illuminated. So Venus will just appear to wink out of a blue sky,
Mhm.
and then it'll reappear at 12:42, 12:43 in that neighborhood on the bright side of the moon.
Yeah, in the afternoon.
Yeah.
So it'll be a daytime thing, which makes Venus easier to look at, but the moon harder.
So something like this happened back in the summer of 2000, I think it was. I was at a shop, I was getting ready to go camping, and there was an occultation of Venus by the moon, top of the sky, it turned out, around, early afternoon. And I was at a shopping center. I just pointed it out to people. It was pretty neat. It's pretty spectacular.
Yeah, good.
Can
Yeah.
I throw in a question?
Go ahead.
Have you ever seen Venus transit the sun?
Yes.
Yes, I have.
Does it do it often?
No.
Oh,
No, no.
It either goes above it or below it.
Yep.
I think it's every 125 years, and then again
Something like that. Yeah, then 8 years.
Then
Yeah.
8 years, yeah. There's a couple in a row, and then another 200 something years. 224?
No, 120 something.
120.
Yeah.
And that used to be the way that astronomers could figure out the size of the Earth's orbit.
Right. And I think the last time Jerry did this was in the daytime, and it was about 2012,
Yeah.
the summer of 2012, right, Chuck?
Yeah.
Sounds about
Yeah.
right.
Because we had family members visiting, and I brought the telescope out and showed it to the little kids, and then that ended up on the front cover of the newsletter the next month.
Wow, amazing. Well, when they're looking at the the other planets around other stars, they do it by the dimming of a Venus out there. I wonder if our sun dims any at all.
Yes, of course.
Yeah.
When Venus transits,
Yeah.
is it a big enough ball on the surface or just a
Yeah.
If you're
little
laying
dot?
if you're laying in your backyard looking at the sun and your eye is calibrated for its luminosity, if a bee flies in front of your eyes, you will see the sun dip, but not by very much.
Yeah. Just a little bit of trivia, Jerry. Yesterday morning was the earliest sunrise for us,
Oh, okay.
and the latest sunset's on the 27th.
Yeah, so we're getting my birthday.
Yeah,
We're getting close to the what is it, the summer solstice.
that's right. It's right in between the two
Yeah.
events. Yeah.
It'll be 21st today, right?
Usually
28th,
about that.
Yeah. Yeah. Latest sunrise, I'm sorry, latest sunset is the 27th.
Okay.
We do a parade in our town for that.
Yeah.
Okay, this is a series of photographs of the Jupiter, and I believe that's Jupiter and Venus, taken every evening up till they actually get as close as they're going to get.
Mm-hmm.
And I didn't include this in the stuff I sent you. I found it later,
Okay.
but it's a pretty cool thing to do.
That's neat.
Yeah.
That's a nice visual, Jerry.
Yep.
Yeah. We watched it every night when we could, and most nights we were able to without the fog. It was really pretty.
Yeah. Yeah, we've been having a lot of overcast out in my end of the Goleta.
Okay.
Okay, well, we did the evening sky. Now we're getting a quick look at the morning sky, planets at dawn. We have Neptune, Saturn, Mars, and Doug.
And by the way, this would be hard to see at 5 in the morning, because these early sunrises.
Yes,
It's pretty glowy in the east,
yeah.
northeast.
And I noticed last night that our day was still bright at 9 o'clock here.
Yes. Yeah, I saw Venus and Jupiter at 8:45.
Mhm.
It was really pretty.
Actually, astronomical twilight was at 9:58 on Sunday night.
Yeah.
2 minutes
Wow.
before the star party would have ended, even if we had a clear sky.
Wow.
Anyway, you get a preview of things that will be in the evening sky later in the year, about 6 months from now.
Mhm.
Is viewing in the morning a little better because everybody's turned their lights off by then?
No, I wouldn't say that. We had my next door neighbor, his house was robbed at 8 in the evening last Thursday.
Wow.
And so all the neighbors around here now leave all their lights on all night long.
Oh, no.
So if it got clear here, I'd have to go around and request that they turn their lights down.
I see.
It's quite bright here. But they did catch the thieves. The ladies, they parked in front of the house next to mine, and the lady across the street, her Ring camera captured the entire caper with 4 guys in black hoodies and 1 woman in a black hoodie, and her white dog got out to act as lookout. And they went into the house, and then the guy came home, and they went running out and all got in the car and took off. And it was a silver, I forget the name of it. I don't know cars nowadays.
Mm-hmm.
Showed the video. They had the whole thing on Ring video.
Yeah.
They showed it to the police, and then a while later we heard that the CHP had caught the car on the freeway.
That's
Ooh.
really good.
A lot of crime, I find out, is due to gangs in LA. And there's only one way to get to LA directly from here, and that's the freeway.
Yeah.
So something like this happens, like a bank robber, it's something they just set up on the freeway and watch them come by.
Wow.
Crime, when you choose crime as a career, it's not the best and the brightest that go into it. So this is a picture of Comet McNaught taken on June 5, a short while ago. This was a very spectacular comet a few years ago. It's a short period comet. It has a period of 5 years.
Wow.
This is a picture taken with a dwarf mini camera, one of those automatic thing that's about the size of a bread box.
Hmm.
And you set it up and it takes it. It's a competitor to a C-Star. And you can tell it's an automated thing because there's a color mottle to the background. See how that's got reds and blues and stuff in the background? They should all
Color
be.
noise.
Yeah. It's color noise, and it's because you don't dither or you don't stack effectively.
Well, Jerry, you said its orbit was 5 years. To me, I'm thinking that means it doesn't go out very far, does it?
No, and as a matter of fact, this is how far out it goes.
Oh, okay.
So this is McNaught right there. And these little comb-like features indicate how far off the ecliptic plane they are. Here it's under the ecliptic plane, here it's above the ecliptic plane. And it's just outside the orbit of Mars. So this would be a spectacular object from Mars. And of course, the Earth is in here, and then Venus and Mercury and the Sun. This picture is represents June 14, 2026, where McNaught is, and the Earth is over here. That's quite a distance, so it's not a real spectacular object this time around.
But Jerry, the only thing that distinguishes that as a comet and not an asteroid is the built-in gas and ice that forms a tail, right?
There's no strong division line between the categories of comet and asteroid.
Really?
So an asteroid that still has lots of volatiles on it, ice crammed away in its cavities and craters. And when the sun hits that, then it spews all this white gaseous fog into the air, and it creates a tail. And it's a comet, and when whatever it is runs out of that, then it becomes a comet. It doesn't do that.
It's an asteroid.
Yeah, excuse me. Yes, it becomes an asteroid. It gets promoted or demoted depending on how you look at it.
But
Better term would just be minor body.
Yeah, minor body. Yeah.
But chances are there are asteroids out there with an orbit almost exactly like that, right?
Yep.
Possibly.
Just that we don't see a tail on it.
Yeah, this is between Mars and Jupiter, and that's the major asteroid belt.
Yeah, this one's for Tim. Tim, wake up. What kind of a triangle would you have there with the Earth, Sun, and McNaught?
Triangle.
Yeah, there's 1, 2, and 3.
Two sides the same, Tim.
Oh, equilateral?
Well, no, let's see.
It looks like a scaling triangle to me.
It is. But two of the sides are the same. Sun to McNaught, Earth to McNaught.
Is Mars,
See the numbers on the left?
Yeah, pretty close, huh?
Yeah, it's pretty neat.
Okay. Huh.
Yeah.
Yeah, see 1.55
Isosceles.
1.55 AU.
Is that isosceles?
No, they'd have to have all the same sides.
Oh, okay.
Right, Chuck, or is that equilateral?
Equilateral.
I geometry, you got me.
I think it's equilateral. I think that would be an equilateral.
No.
Yeah.
Equilateral is all three sides the same.
Yeah, all
That's
three
correct.
sides.
Isosceles may just mean two are the same, huh?
I
Maybe.
think so.
ISO usually means same, so
Yeah.
I think it's isosceles.
Yeah.
Okay, so there you go, Tim.
Yep.
There's geometry
That's
for the
how
day.
far- Shows how far high school math is getting in our background.
We do math every day, Jerry.
Yes.
Yeah.
Okay, so this is a picture of McNaught from the Earth looking in the east. The circlet of Pisces here in the morning. Oh, it doesn't give the time. This is, let me get down to that caption. 2 hours prior to local sunrise.
That sounds right, because you see Saturn there, Jerry? Saturn comes up ahead of the sun.
Yeah, okay. And this is, the guy is pointing out, the earlier guy that took the picture with the dwarf mini smart scope, put into the catalog, it has McNaught in its memory bank already when you get it. And it's referred to as P/220.
Okay.
And so he put that in and he was able to, it went right to the comet.
But
So,
the astronomer who found it was named McNaught, probably.
yeah,
Yeah.
these little dwarf cameras and sea stars and stuff that cost about $400 to $500 for a fully automatic thing. You just set it down and it figures out where it is, and then it goes to where you ask it to go to after a break-in period or a calibration period. Those things are getting very popular. We have like 6 or 7 of them in our club, and a few
Oh,
of them
more than that. Yeah.
more equipment.
It's probably going to ruin my December speech.
Yeah. How bright is it, Jerry? Magnitude, McNaught.
I don't know.
Oh, okay. Okay.
I
Just
think it was
curious.
It
8 or
is.
something like that.
It is not a
Okay.
visual magnitude. Let's see.
Yeah.
Do.
Especially in the glow of the sunrise.
Yeah.
Huh.
Oh yeah, I didn't capture that.
It's okay.
Geez. Yeah, it's captured in a 2-to-1 resonance with Jupiter.
Oh, wow. Mm-hmm.
So the reason this comet doesn't have a C/2026 or 20 an address on it is because it seems different than all the others.
Well, it's P/220
Yeah.
for
Okay,
periodic comets. C is
Yeah.
just a comet that's not periodic.
Does 220 stand for 2020?
No, that's
See?
the order in which its orbit was determined.
So we've seen this sucker forever, for
No,
100 years.
no,
We haven't? We just
no.
I thought it was 5 years. Every 5 years, it's
We have
within-
the opportunity to see it every 5 years. That's its orbital period.
Mm-hmm.
But it didn't kind of give a real big display until, I don't know, what didn't capture that either. But
1998 or something like that.
yeah, and that's when everybody goes, "Ooh, wow!" I mean, it was really dramatic. You couldn't avoid it in the sky, in the evening sky.
and a Scotchman found it.
But now it's not up to visual magnitude.
Okay.
Okay,
It's about 10.5 to 11 right now.
Oh, okay. So real dim.
Yeah.
okay.
Okay, we're going to talk about the Earth's place in the spectrum.
Yeah,
This is fascinating stuff.
this is, yes. What is going to happen? The whole point of this is that there is in the, this is the wrong out of order.
Mm-hmm.
So this is looking for exoplanets, and the idea of exoplanets is we're looking, of course, among other things, we're looking for the physics and the science of planet formation, but we're also looking for another Earth. And so far, we've only had the criteria on that it be in the habitable zone around a sun-like star. And those are pretty hard to spot, but we have found a couple, such as TRAPPIST-1e, Kepler 542, and Proxima Centauri b. And those meet that criteria of the habitable zone. But the idea is to try and get an exact copy of the Earth at some stage in the Earth's development. Remember, the Earth is 4.5 billion years old. So if you take a spectrum of the Earth, today we know what the Earth spectrum looks like, but we might be looking at an equivalent Earth that's only half the age of our Earth, or even a quarter of the age of our Earth. And we need to look for spectra that are like that. And so right now, NASA is in the very initial stages of developing a program called HWO, Habitable World Observatory. It's the next big telescope in their series, like the Hubble and the James Webb Telescope, and then the HWO, which is like, who? Anyway, it's Human World, Habitable World Orbital. And what they're looking for is Earth-like planets at some stage in Earth's development. And this is about the planning process for that. What did the Earth look like? So we're looking for another Earth, but which Earth? The Earth when it first started out and there was no life, but there will be. Earth in the early stages when there was no oxygen. And so the spectra of these things has been worked out, the different parameters they're going to look for. And doing that, you need a very big telescope. So it's going to be about the size or bigger than a JWST. And it's going to cover the oxygen line, the most desirous thing to see in another world, water, CO2, oxygen. And some of the lines are very close together. So getting a high resolution spectrogram is quite a bit challenging. It's like taking a very high resolution astrophoto. There's going to be a lot of image processing in it, and they're working out the initial details of it. They're in what we called, where I worked, a white paper stage. And then they're going to consider the cost. They're going to consider possible designs, and then they're going to consider the cost. And then they're going to consider better designs later and stuff like that. So anyway, this is what we know about planet masses. It's where we are now in basically these are exoplanets that discovered by their different methods, transit, radial velocity. This is where the star it's going around moves back and forth. Transit timing variations, things like that. And we're including in this our own solar system. There's the Earth, Venus, Mercury, Mars, Doug, Neptune, Saturn, Jupiter. I'm trying to place those in there. Now, the Earth, you see, is on a kind of and Venus are in a bare spot down here. We don't have a lot of candidates to look for. So we're trying to extend, and these are things that we've already found, but they're not Earth-like in the sense. Many of them may be at the right orbital period, which is what, 360 days. So that's a line going straight up here. So all these take 1 year to transit or go around. And this is in terms of, now all these charts are going to be in terms of Jupiter masses, not Earth masses. So one is not Earth up here. Earth is down here at 10 to the minus 3, 3 times 10 to the minus 3 Jupiter masses. So that's where everybody wants to look, and they want to look spectroscopically. So that's what they're aiming for.
Well, what's the difference between the purple dots and the blue dots?
Purple was where they measured it by transit of the planet in front of the star.
Oh, okay.
And the green squares are where they measured the radial velocity of the star as it went back and forth around its barycenter. And then there's transit timing in the little diamonds. There's one right there. And then there's direct imaging, which they have to be very far away from the star. So their orbital periods are going to be very long.
I found that really interesting, Jerry, that they were grouped up to the upper right.
Yeah. And eclipse timing variations are these red crosses up in here. And then micro lensing, there are a few of those. Circles, there's one right there. You only get one shot at it.
Mm-hmm.
And then there's pulsar timing, orbital brightness modulation, astrometry. That's where they measure it as they can see it. Pulsation timing variations and our solar system. Okay,
Well,
so
I've
go
heard
ahead.
that we found 4,000, between 4,000 and 5,000, but that can't be the number of dots on we're looking at.
It's up to like 6,000 now, I think.
Yeah, I think it's this is as of 6/4/2026. So this is Exoplanet Archive from Caltech. So I would guess this includes pretty much everything except the 1,000 that we discovered last week. But
And I'm guessing the majority of them are gas giants because they're the ones we can probably see.
these up here around 1 Jupiter mass, those are probably going to be gas giants.
Those are the ones that are easier to find. That's why it's a selection bias.
Yeah. So
Okay.
we're fighting the odds to fill in this region down here. The hurdles to doing so with a satellite is most of the Earth-sized, potentially rocky planets discovered so far have been detected via indirect message. methods such as transit or radial velocity. So that is these purple things up here and these green squares. So it's referring to that. And to capture a planet's transmission or emission spectrum, that's what we're after now. Stellar light must pass through the thin ring of the planet's atmosphere during a transit, or the planet must be directly imaged. Each of these things are very challenging. So the scale problem is Earth-sized planets orbiting the sun, a G-type star, are incredibly small and dim compared to their host, making their atmospheric signals exceptionally faint. But that's what they're going for. The current technology is space observatories like the James Webb are currently pushing the boundaries of transmission spectroscopy, but we're primarily targeting larger planets or rocky worlds orbiting small, cool M-dwarf stars or G-stars.
Well, are you going to be able to explain to us how the telescope works, how it's much better?
I have no design for the telescope that shows how it's going to meet these challenges. That's in the guys with slide rules in the back room right now.
Jerry, you might have already covered this, but why would they use spectroscopy as their choice?
To look at the planet atmosphere.
Yeah, the planet's atmosphere is taken as the real signal of life or potential life.
Okay.
Not just the habitable zone and the period around it. Not just the mass and the habitable zone. So they're looking at Earth's history a lifetime, because when we look out there, the Earth is 4.5 billion years old. We don't know if we're going to spot an exact copy of us, but when it was only 2 billion years old. So we got to be open to that, to the evolution of the Earth.
It might be redundancy, but wouldn't it be easier to detect these things using another method and then throw the spectroscopy once you know where they are?
Yeah, that's what they're going to do.
Oh, okay.
Hang on.
So my thinking isn't all broken.
No.
That's
the
okay.
two most important things would be what? Water and oxygen, right?
Water, oxygen to CO2 ratio, things like that, nitrogen, ozone, hopefully.
Methane.
Well, the spectroscopy give us the difference between an ocean and clouds of water?
Yes, if your starlight goes through the atmosphere, it will glint off the ocean, but it will pass through and show absorption lines for the atmosphere.
Okay.
So anyway, let's look at Earth's history or timeline, because which Earth it is, we got to know that. So here's several billion years ago, the Earth differentiates. The gold sinks to the middle. Then we develop an ocean. Then at 2.4 billion years, we switched over from cyanobacteria. Oh, I should read both ends of the line. 6.6 billion years old, we formation of the Earth. Here, the Earth obtains, once it's differentiated, it obtains a magnetic field. So, and we won't see that directly. Then it obtains an ocean.
Actually, they're detecting some of that, from variations in the spectrum.
Yes, they are, but not a complete spectrum.
Yeah.
Yeah.
I'm sorry, I misunderstood. What's missing?
All the things to the right yet.
Oh, we didn't start out with a magnetic field?
No.
No,
Really?
there had to be an Earth with a dynamo in it to make the magnetic field.
Okay, and that's metal mostly, isn't it?
Yeah, it sinks to the bottom, and it has specific currents in it.
It has to be molten and moving around too,
Yeah.
which
So it's solidified on Mars, for example, and they lost theirs.
Yeah, Mars has passed through this stage and the magnetic field has died away.
Got it.
So it's beyond now. So anyway, then we get an ocean, and then we have the first life, which is a cyanobacteria, which means it flourishes in an oxygen-free environment, but it emits oxygen as a byproduct. Eventually, it emits so much oxygen into the atmosphere that it poisons itself into extinction.
Oh, God.
And then we can see, like we're doing right now with CO2. Anyway, so we will see at that point oxygen in the atmosphere. 2 billion years later, well, this is the cyanobacteria thing killing itself off. Here you get some oxygen from that, and it's producing the O2. What was that? And then we got snowball Earth. And so we've got to be prepared for this. 7 millions of years ago is the modern oxygen level. Now, back in this age, we had oxygen levels. Well, I guess that was in complex life. We had oxygen levels that fluctuated at one point up to 30% oxygen. We're currently at about 21% or 20% oxygen. Then we develop complex life, and we get all the chemistry from that, methane and stuff. So the spectra of the Earth is going to change down here. So we can't just reject it because it doesn't match our now spectra. 420 million years ago, we got land plants, and that was possible because of an ozone layer. And now we're Homo sapiens, where we can look for infrared signals from our nighttime side where we have cities.
Huh.
So these are the past histories of solar system planets. We won't go in detail on it, but Mercury, Venus, the Earth, we just went through the Earth. But this is the current spectra that these planets will show. And here the Earth is nitrogen, oxygen, argon, and other gases. So Venus is CO2, nitrogen, other gases, and clouds of sulfuric acid. Mercury, no gases. Well, a little hydrogen, 22%, 29% sodium, vapor, oxygen. But these are very small amounts.
I'm surprised that Mars and Venus have similar composition.
The Mars, Venus, and Earth had similar origins and histories. Just that Mars ran away and Venus never got started, apparently. So anyway, these are the types of things they want to differentiate between these types of spectra in whatever they see in a solar system around a G or M type star. Now, the technique they're going to use is this is the star, and this is the planet going around here. And you will see radiation from the star transmitted through the planet's atmosphere. That's this little green line right there as it goes around. You will see a thermal radiation and reflected light from the planet as it disappears. So this shows you at this stage what H2O and methane is going to look like. And this shows you down here in transit, what they're looking for is water, methane, CO2, and methane.
Oh, that's interesting. The different transit and eclipse is showing different things.
Yeah, you're looking at different aspects of the light, whether it's transmitting through the atmosphere or it's bouncing off the atmosphere.
Interesting.
Yeah.
Does methane add anything to life?
It adds smell to the aroma.
Actually, methane is odorless, but it's a byproduct of life, and there are bacteria that can use it as food. So
yeah, somehow cows manage the methane with odor.
Yeah,
yeah.
Those are sulfur compounds.
Yeah.
Titan around Saturn is nothing but methane, isn't it? Lakes.
It's ethane and methane.
Yeah.
Or one of our speakers once said, and I can't stop thinking about it, ethane and methane.
Yeah. That must have been Julia Knott.
It was a woman, and she was from England.
Yeah, it's the British.
Do either of those products you just described get mined and turned into petroleum and plastics and stuff like that, or is that a totally different?
No, this is part of the petroleum spectrum, these organic molecules. When you get petroleum out of the ground, you get all these different compounds from gaseous to tar, and you even get helium, which it's our helium source. To get helium is the natural gas vents. Methane as natural gas and ethane, and that's what's piped into your home once they add the stink to it, because you're right, it doesn't smell.
But other than the letter M, what's the difference between methane and ethane?
An extra carbohydrate hydrogen bond.
Methyl.
Yeah,
Well, there's a million different compound molecules, aren't there? There's
it
propane,
seems like that.
butane.
Sugar.
I was deciding whether I wanted to be a physicist or a physician one time as a sophomore, and I got the OChem book. It was about this thick, and it had tissue paper on it for pages, and you could see one page through the other almost. And I looked and I thought, I'm going to have to memorize this. And I thought, okay, physics is it.
Yeah.
Okay.
So this is what hot gas giants such as WASP 39b looks like, atmospheric compositions, measured in that way. This is from the James Webb, and this shows the carbon dioxide band.
Wow.
In infrared, this is 3 microns. The cutoff at the visible end for near IR is 1 micron. That's where silicon cuts off its ability to detect, even with its indirect method. This is out here in mid wavelength, and this is SWIR, short wavelength, and then from here on is mid wavelength. So
I never understand the infrared. I hear when you guys talk about it, it just baffles me.
there's not much to it. You take a photon from visible and you just stretch it like that, and that's infrared.
Oh,
It's longer wavelength.
Yeah, that's all there is to it. Nothing magical except you can't see it.
boy, they must take a really small guy to stretch it.
Yeah.
And or a big magnet. But there's two animals that can see infrared. And
Really?
one is a mosquito. They hone right in on you at night because you are the source. The nighttime sky is dark, except that human beings at their body temperature glow like a light bulb. Mosquitoes have no trouble finding you.
What's the second one?
The second one is a rattlesnake.
Snake.
Oh,
Pit vipers, they
actually-
have 2 sensors on their nose. Go ahead.
Yeah, all kinds of snakes have heat sensors.
Yeah, the class of pit vipers is what they
Yeah.
are. Yeah.
Well, even pythons do too. They have lip pits.
Okay. Lip pits.
I wish I didn't ask.
So that's used with snakes. It's for terminal guidance. If they sense your heat is bigger amplitude on the right side, they'll turn toward the right for terminal guidance to fine tune their bite.
I'm telling you, Jerry, the person to stand next to when there's a lot of mosquitoes is Chuck.
Yeah.
Now, that was just about to mention that. There are differences with people, and some people have a skin condition that is far more emissive of infrared light, and some people like me don't. So I'm usually standing around a campfire wondering why everybody's slapping the hell out of themselves.
I never knew that. I never knew that.
But so red is on the bottom end of the spectrum we can see, and right next to it is infrared.
That's right.
Okay.
Oh,
That's what
okay.
infrared means, is beyond red.
Oh, okay.
The beginning of Roy G. Biv, isn't it?
And that was Herschel that discovered it.
Are they lined up as far as the frequencies? ROY, G, what?
Yes.
Oh,
Red, orange?
Yeah, red
yellow?
is lower frequency, and
yeah.
violet is higher frequency.
Yeah, wavelength is inverse to frequency.
Tim, have you heard of that? Roy G. Biv?
I have, but I forgot it until you said it. And I'm really glad you asked that question about the red and then infrared, because it's all starting to make some sense here. And
then
some of the stuff Tom taught me in mirror grinding is starting to make sense too here.
Okay.
But right below that then is your microwave, and then my radio career. All the
Folks, there's a lot of stories about Tim Crawford making his mirrors
Yeah,
shops, but we don't have time to go into
no,
those.
you don't want to go there. Bruce
Oh,
Murdoch used to just crack up at me.
Was it? We have one guy that was, at the time, he was making his 6-inch mirror that he started as a teenager. And I think
That's Ed Edwards.
Ed Edwards. Yeah, I'd been working on it for 48 years.
Yeah. I told him this has taken me a long time, and he goes, "You think?"
Now, folks, if you want to grind a mirror, it's a very rewarding Zen-like experience, but it only takes like 1 week if you stick to it and follow directions.
I tell people when they ask me, "How long did it take? How long does it take?" And I said, "Well, we had a guy that did a complete mirror in 30 days." And I said, on the other hand, I had one that took 50 years.
Yeah.
So it's just, I said it probably takes.
See, you have to stay out of marketing for mirror making.
Yeah.
I made a mirror front to back in 7 days one time.
Wow.
I worked on it 4 to 6 hours a day.
That's really neat, Jerry.
Yeah.
What size?
6-inch.
Oh, okay.
6-inch f4.
Ooh, that's tough.
Yeah.
Now, this is the current view of the simulated Earth transmission spectrum at for a modern Earth spectrum. I don't know what the 0.03 AU means, but this is what you would look at from that distance for Earth. Relative transit depth. This is for a star transmission through the modern Earth spectrum. And this is what they're shooting for. This is what the spectroscopy has to resolve cleanly. It has to, and this is the tough part, is these two close O2 lines, this water and the methyl line, and this methyl and water line, and this methyl and CO2 line. These other things are, on that scale, relatively easier to see. But this stuff is very, very demanding to get good information on this. Now, you may have seen or heard within the last 6 months that we saw a planet that we believe is a water world, and someone suggested there's life on it because there was a disulfur compound, as I remember it right? And they said that's a harbinger of life there. And then they showed the spectrum taken by the James Webb, and I would have been hard pressed to see lines there. It's a long, typically infrared spectrum with a few bumps in it that were very vague. It was nowhere near a definitive spectrum, in my humble opinion.
Mm-hmm.
Yeah, the complaints were all that it was a very noisy spectrum, so you can't really make that determination.
You remember, was that on the workshop? No.
Yeah, we talked about that.
Okay.
No, we didn't talk about it in the workshop. We did it at in this show about 6 months ago or something.
Okay.
So anyway, this is a high resolution spectrum, and this is what we need to have this new future WHO observatory to be capable of for things that are elsewhere in our galaxy. You know,
Wow.
we're 29,000 light years from the core of our galaxy. And so we want to have something that we can see, say, up to the 20,000 light years away, and we can still get good spectra from Earth-sized planets orbiting these sun-like stars. No problem. I'll have it ready by Tuesday noon.
Yeah. A radio telescope cannot detect those types of objects?
Radio telescopes can detect their portion. They can detect all sorts of things in their portion of the spectrum that they can see. Radio telescopes can't see this portion of the spectrum. This out here at 25.25 microns, this is in the violet, ultraviolet, it's ozone.
Oh.
This is in the green area where the sodium doublet is, so they have to discriminate against sodium. This is getting out in the red region, and here at 1 micron, you're in the infrared. This is the near infrared. This is a shortwave infrared all the way out to 2.5 microns. So this is visible and infrared. So radio will not see any of these lines. There will be an equivalent set of spectra out there at the radio wavelengths.
Can they detect the exoplanets at all?
I don't know. That's a good question, because when you have an array, you see these things on the ground with the antennas, and they're spread over, a big pasture. all of them are looking at one pixel in the image.
Oh,
And
God.
look at it for a long time. And then the next night they look at another pixel for a long time. In the meantime, a transit has occurred. So you don't
Yeah.
get good time resolution like you
Yeah.
would with visible light.
Yeah. So possibly not. Okay.
So now these are examples of previous candidates on how things evolved with our technology. This is the initial finding of the TRAPPIST-1 system. The star is always A, then they found B, C, and then a D maybe. And here, this is what we currently can resolve with the TRAPPIST system. We have the A, B, C, D, E, F, G, H. So that's 1, 2, 3, 4, 5, 6, 7. And someone proposed naming these after the seven dwarves. So,
I like it.
but
Don't be,
B is the one here that's in the habitable zone.
that would be bashful.
Yeah, this one here, but the star is a dwarf star. It's a M-type star. These are very violent stars. They throw flares and stuff out because they don't have much mass to hold them back. And so planets out here are probably do not have an atmosphere at all. They have probably been completely sanitized by a violent star. So we're not looking for these.
Huh.
So
You know,
this is
yesterday, Jerry, the kid in the by the observatory was talking about the M-type or the red dwarfs,
yeah,
and he was talking about how they are really violent, and I didn't know that. So you
yeah.
repeating it here is really interesting.
Yeah, I heard it I heard it on the grapevine. So this is a artist's conception of the outside of the HWO observatory looking at the Earth. And but I have no drawing that I've been able to find of the proposed guts of it, how they're going to do it. There are a lot of sophisticated spectroscopy measurement instruments out there that are easily capable of doing this. But remember, they got to do it on a short time frame, and they've got to do it on a paucity of photons.
And they're going to, when is the planned date for this to be launched?
If I didn't put it in the notes, I don't have it. Let's see. Scale size.
I apologize for not seeing this in the notes. I only went partway through the notes this week.
Okay.
I'm not seeing any proposed date.
Okay. No, it's with the current fluctuations in budget. I don't suppose anyone's going to take a guess at that. It's still here. The mission is still in the very early design phase and is years from launch. There's a paper posted in the archive preprint server that, well, that's where I got this information from. So
The early to mid 2040s is what I've got.
okay. Okay.
So ways off.
Yeah. So anyway, I think that's where we're going to stop it, and we'll pick it up next time here.
Just one quick question about how many natural elements are made out of stars? We have them all here, don't we, on the Earth?
Up to iron.
Iron is everything above
Well-
that is made by man?
Well, no.
Oh.
Well, I'm just curious.
Fusion processes go up to iron. That's the most stably bound atomic nucleus. You can get a little bit of nickel and things. And then when you have the explosion, that's when you make heavier elements. Or when you have colliding neutron stars is when you make really heavy elements.
Yeah.
So basically everything is out there that's on the Earth.
But all these things that are indicated by the spectrometer are the really dominant things that there's a lot of: hydrogen, oxygen, nitrogen, etc. Rare
No.
earths would never show up.
No, there's a lot of metals out there, heavy stuff too.
Yeah.
These are the things that form the biosphere.
Yeah, we're looking for life here. So we're looking at things that are biological.
My question is simply, I wonder if science thinks there might be planets that don't have certain elements. They didn't get cadmium or
argon or xenon or whatever.
The relative proportions might be different, but you're still going to have a mixture of stuff.
Everything will be there.
Yeah.
I wonder
Except
if
one of-
anybody met the very friendly man from India, Arjun Iyengar, on Friday night. He was
Yeah.
he was a good
You
guy.
remember?
I
Tim,
found out, I talked to him. He's not the guy that phoned us from India.
no, but you wanted to know the name of the guy from India that used to listen to us. So, Tim, do you remember? Did he give us his name?
No, he didn't. He just had a moniker on the
Okay.
thing, and I can't remember what that was. It was over 5 minutes ago.
And I got to tell you, Tom, I enjoyed your German potato salad Friday night.
Yeah, that was
Oh,
good.
thank you.
Yeah, that was very good.
Oh, thanks,
Really
Jerry.
good. And then I'll get my dark glasses back that I left there from you, Chuck, maybe at the next meeting.
Yeah.
We'll see you guys next week. We'll close up shop for now and be back for number 278, SBAU Astro Hour. Thank
Yep.
you very much
Live
for
long and
watching.
prosper.
Once again, very interesting, Jerry. Thank you.